Example number 4, graph one cycle of, and I can see that it's a sine. And so immediately I know, okay, well, sine starts in the middle and then heads up. So that's helpful to me. If it's negative, that means I'll have to head down, but it's not negative. Also, what's worth noting is taking a look at this and saying, oh, well, 5 over 2 is 2.5. So keep that in mind as well. Now let's take a look here. Oh, I see some weird numbering here. Usually it's got pi, but I got this stuff. So hopefully that's okay. First step, we're going to see how far down we drop. So step number 1 here, -2. So 1, 2. So -2 is our vertical displacement. That's here, down 2. And then we've got up 2.5. So we have to go up 2.5 from there. And remember, every tick box here, every box is worth a half. So 2 boxes is 1. So that's 1, that's 2, and a half. So I guess that's what, 5 boxes. And then 5 boxes up as well. And this is at 0.5. That's my height. -2, -4.5. I think. So 1, 2, 3, 4 and a half. Yeah. So that's my minimum and my maximum. I'll write that down. My maximum is 0.5 and my min is -4.5. Domain, I can even do that right now because I know that these graphs go -infinity to infinity, and then I can do my range. That's just based on my min and my max. So -4.5 to 0.5. Okay. Now I can actually no, I can't draw this. I gotta do my period. So period is 2 pi and then do the opposite, which is divide now by b. I have no idea what my b is. So let's take a look. It's a number in front of the x. It's a pi. So I'll divide by pi. Those cancel out, and I just get a 2. So my period is 2. So that means I got to end here. Got to end at 2. And then I want to break them into equal quadrants. So I'll cut that in half to 1. Cut that in half again. That's easy enough to label, 0.5. And then cut this in half. And that would be between 1 and 2 would be 1.5. So those ones are much easier to label than the pi over 12 stuff we were looking at the other one. So let's actually graph this now. These are my tick marks. This whole thing is mostly down below the x-axis. Now, I am is it sine? I think I said sine, so I have to start on the middle line. So I'm going to start at the middle line. And it's not negative, so the next tick, I'm going to head up to the top line. And the next over here, I'm going to go back to the middle. And the next one here, I'll be down at the bottom. And the next one, I'll be back to the middle. So I've drawn a complete cycle here. And there we have it. So that is now, I've drawn this. Keep in mind that the PDF looks a little bit nicer. But I was able to do all of this. Oh, the amplitude, I didn't do that. The amplitude here, A, was 5, the absolute value of 5 over 2, which is still just 5 over 2, or 2.5. You could write 2.5 as well. Okay, so that's sine, starts in the middle, heads up. Perfect. So next one. Okay, well, the next one's a tangent. And let's take a look here. And after that, I'm done. So tangent was a lot different in that we had to go over pi over 2. So this is 1, 2, 3. And we had these, this is what the original one looked like. So you went over pi over 2 to the right and went over pi over 2 to the left. So negative pi over 2. And then the pi over 2 on the left and the pi over 2 on the right, if you put them together, you get a whole pi, which is what the period was. Now, we might have things that are going to be stretched a little bit. So let's take a look. The first thing that we're going to do is we're actually I'm going to look at this period, because that helps set my vertical asymptotes. So the period, which is right here, is not 2 pi over b. But for tangent, the period's not 2 pi, it's just pi. So the formula to find your period is pi over b. And in this case, our b is a half. So I don't like dividing by half. I said I want to multiply by 2 over 1. Pi times 2 over 1 is just pi times 2, so 2 pi. So my period here is 2 pi. So what I'm going to do is I'll shift these. Because a full cycle is 2 pi, I'll put half of it on the right and half of it on the left. So I'll do pi on the right, and then I'll do negative pi. I think it's 6. 1, 2, 3, 4, 5. Yeah, right there. So I'll do negative pi on the left, and that way this distance is pi, this distance is pi, for a total distance of 2 pi, which is 1 full cycle. So I've done that. I'll make this in red here. And then what I had said before is that this thing starts in the center, and then halfway it goes up to 1. So halfway will be 1, 2, 3. So halfway, and 1, 2, 3, halfway, it went up to 1. So we started in the center, went up to 1, went down to -1, and we had this looking graph. So that's what we traditionally had. Find the halfway point and go up to 1. Now, we have a vertical shift here. We are shifting this thing up by 1, and we have a stretch. So instead of going up to 1, we're now going to stretch it and go up to 2. And instead of going down to -1, we're going to go down to -2. So now we're looking at this. So it's got a vertical stretch. So that would be number 2 here. We've just done a vertical stretch, but there is a shift that we need to do where we need to shift this thing up. I don't know why it says 2. This is a 1. So we need to shift this thing up by 1. So all of these points are going to go up by 1. Oh, 1 is, I said 1, but every 2 marks is a 1. So now I've centered myself right here. Now that's the middle, up by 1. And then here, I now can go in the middle, go up 2. And here I can go in the middle, go down 1, 2. And that is my graph. So there's a lot going on here, and there is a practice one to do as well in the worksheet. But that's about as complicated as I'm going to make it. I'm not going to shift this thing left or right. I'm just going to have find your period, put half of it on the right, half of it on the left. Find out how much you've raised this thing, so you can find out your middle line and center it there. And then that will tell you, if you go halfway, how high should you go. In this case, it was go up by 2. 1, 2. And then over here, halfway, how low should you go? 1, 2. If it was a 3, I would go over, go 1, 2, 3. Same as on this side. Go 1, 2, 3. So these questions take a lot of practice. Unfortunately, I can only give you one example here. So it is worth your time to go try the one in the worksheet as well and rewatch this and make sure you fully understand this. I forgot these parts down here. So the maximum and min. So what is the maximum that this thing gets? Well, the maximum is infinity. That's the highest. So we can write y equals infinity as the top that goes up to infinity, and negative infinity is how low this thing will go. Now domain. So domain happens when x can be any real number. So you say xer. X is an element of any real number. Or I guess you could say negative infinity to positive infinity. But, there's a big but here, x is not allowed to be these vertical asymptotes. So when do these asymptotes happen? Well, they happen at pi and then negative pi. And there's this gap of 2 pi in between. So there has to be a gap of 2 pi. So this is 1 pi. You have to have a gap of 2. So 1 plus 2 would be 3. So we would be here. And then that would give us, remember, because this distance was pi and pi. Therefore, that's a total distance of 2 pi between the asymptotes. So this distance would be 2 pi. And then you do it again here at 5. Because that distance is 2 pi. So every time you have 2 pi, that's what the period is. So for our domain is allowed to be any number we want, but it's not allowed to be pi, 2 pi, not 2 pi, 3. The next one was 3, I think, right? 1 pi, 3 pi, 5 pi. So 1 pi, 3 pi, 5 pi, and then it's kind of dot, 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 and then dot, 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 dot on the left. You can see the pattern. So that would be the domain. A nicer way to write it is x is not allowed to be, you can say pi, and then plus the period is 2 pi n, comma, n can be any counting number. Now in class we go over this a lot, where we'll do the very first one, the very first asymptote is 1 pi, and then it takes 2 pi's after that. And you can do that any number of times you want. You can have as many 2 pi's as you want. So that is considered the nicest way to do that. You start with the first one, and then you add the period. So do I have a spot here for, vertical asymptote? That is what this is right here. So to write the vertical asymptote, it's always the way that I like to write it is your first asymptote. This is kind of the formula for this. Your first asymptote plus your period n. Period times n, where n is an element of the integers. So this is the formula. And we've already done the period. We did it right over here. We found our period to be 2 pi. So when we do this, the first asymptote happens at 1 pi or negative 1 pi. Doesn't matter. You can choose either one. This happened here at 1 pi, but we also had one at negative 1 pi. I like to choose the positive one. And then it's at a plus sign, plus your period, 2 pi n, comma, n is an element of the integers. So that is, and you don't need this giant space here, but that's when your asymptotes happen. And as soon as you find that, you plug that into your domain. X can be any real number, except it's not allowed to be this thing. And that's where I got this. This is exactly what I had. 1 pi plus 2 pi n, where n is an element of the integers. Our amplitude is the number in front of the tangent there. So it was a positive 2. So our amplitude is 2. So you can just write that down here. Amplitude equals 2. And our range, we go from negative infinity to positivity. How low do we go? Negative infinity. How high do we go? Positive infinity. It's right here with our max and our min. So what is the most difficult part about this? It would be finding out where your vertical asymptotes are. If you can do that, then you can do this. It's just x is an element of the reals, except it's not allowed to be, and you just copy it down here. So this is probably the most difficult part of all of these. There's no more, right? Yeah, of all of these here.